Okay, today so last class we here. This one we looked at simple random sampled, which was a good one. It's actually the best one, but not always the one that we're going to use. So today we're going to look at some other sampling methods. So one of them that we're going to look at is called stratified random sampling. So in stratified random sampling, what we're going to do is we're first going to put our individuals in our population into groups. These groups are called strata. So what we want to do is we want to put them in strata that share characteristics of some kind that are thought to be looking at what we're measuring in our study. So for example, if we were talking about the school, DeSoto students, before it was just a random sample of all of them, maybe we group them by if you're a freshman, sophomore, junior, senior. That would be put them in strata. So maybe I have 4 strata there. So then a stratified random sample is going to take a simple random sample from each stratum, and then we will combine them to make one big sample at the end. So it works best when individuals within each group have a similar thing that we're measuring, or there's going to be a difference between them. And then we can choose the strata to have similar responses within our strata, but different responses between each strata. So maybe freshmen are going to have the same answer, but seniors would say something different. That's kind of what we're looking at. Also, the random samples do not have to be the same size. They can be, but they don't have to be the same size. So when we're picking a stratified random sample, first you're going to classify the population into their strata and name what are your strata. Then choose an SRS from each sample and put all those together to make one big sample at the end. So for example, here another one, maybe a business has a list of clients and he is going to separate them by their ethnicity. And so instead of just taking a random one and maybe missing somebody, they're going to put them in strata, and then they would take a sample from each strata. Okay, and then each one of those samples, maybe we take 10 from here, 10 from here, and 10 from here, then our sample size in the end would be all 30 of them. We're just doing 10 from each strata. So that is stratified random sampling, not to be confused with our next one, which is called cluster sampling. So cluster sampling is going to put individuals into what we call a cluster. The cluster, they may have nothing in common. The only thing that's common is that they are located near each other. Okay, that just means everybody that's in that cluster are together. So for example, in the school, if we're doing DeSoto High School again, maybe my sample or my clusters are each classroom. So my classroom would be one, Mr. Soxy's classroom would be one, Mr. Runyon's, everybody's classroom would be a cluster. So in cluster sampling, we're going to separate them into those clusters. Then we are going to randomly choose clusters, and then we're going to include each member from the clusters that we choose. Okay, cluster sampling works best when the individuals are mirroring the population. So example, like a lot of times they will do this to get information maybe about DeSoto, the city of DeSoto, and our clusters might be a city block. They like to use that. Okay, it's very important. It's very easy because it saves time and money because everybody they're sampling is right there together instead of spread out all over the place. So if we look at taking a cluster sample, first divide the population into groups, into our clusters. Okay, they should mirror the characteristics of our population. Then choose an SRS of our clusters, and all individuals in the chosen cluster are included in the sample. Okay, so for example, if you're doing this, maybe we look at our classrooms. Maybe we have 50 classrooms. Of the 50 classrooms, we take a simple random sample and we're going to choose 5 of them. Then we would ask everybody in that classroom the question. Kind of be an example of cluster. Okay, another one that we have is called a systematic random sample. So a systematic random sample is going to select from an ordered arrangement of population by randomly selecting one of the first K individuals and choosing every Kth individual thereafter. So in this example, think about maybe you want to know how much students were spending at lunch. So you stand at the lunchroom, you start with the first student who goes through, and then every 10th student after that, you would look at them. That would be systematic. How much time does someone take in the drive-thru at a bank? We look at every 5th customer. That would be systematic random sampling. Okay, it's useful in certain contexts. Exit polling on election day, they might ask questions to every 10th person who voted. Okay, one thing you want to be careful of, if you know there's a pattern in what's happening, you want to make sure that you aren't picking something that coincides with that. So say going through the line, you know that they go freshman, sophomore, junior, senior. You wouldn't want to pick like every fourth to where you were only asking seniors. So that's something to keep in mind with systematic. Okay, so when we do samples, things can go wrong. So bad sampling obviously is bad. It's going to create our bias. You can do some methods that will help reduce that by choosing a better sampling method. But there are some things that we just can't avoid or are very difficult to avoid to make errors. So of that, we have a few that we're going to look at. The first one is called undercoverage. This occurs when some members of the population are less likely to be chosen or cannot be in the sample at all. So think about if we were looking at city blocks, because we were looking at the city of Soto, and you're just taking houses on a city block. If someone is homeless, they would be left out of that population because we're only looking at homes within the area. Another one is phone books used to be a way that people would randomly call people. If you had an unlisted phone number, you wouldn't be in the phone book. So that would be undercoverage because you're not in the population. Non-response. This occurs when an individual chosen for the sample can't be contacted or refuses to participate. Okay, I am one who refuses to participate sometimes. Think about when you get that random call and will you answer some questions for us? No, and you just hang up. Like that would be refusing to participate. So that can happen. Think of the example you had in your worksheet 4.1 where they sent out 1,000 samples, but only 137 or something came back. All the rest would have been non-response. No one answered them. We also have response bias. Okay, this occurs when there is a pattern of inaccurate answers to a survey. So maybe people are lying in their answers, not telling you the truth. That can also happen. And then another big one is wording of questions. It's important not to influence the answers given. You want to keep it very simple so that they don't think a lot about what is happening. You don't want to or sway them to say yes or no one way or another with what your question is asking in the wording. So these are possible things when they tell you what's wrong with something or what's the bias. These are things that might happen that you will look at. So that is the end of today. You have an assignment on sapling and a worksheet to complete. Let me know if you have questions and have a great day.